Rates. A rate is a ratio of two quantities measured in different units. A unit denotes an individual item or a single entity. It represents a unique, distinct object from which measurements are derived. Here are some examples of rates. 4 participants to 2 teams, 5 gallons for 3 rooms, 8 burgers to 2 tomatoes. A unit rate is a rate with a denominator of 1. It is often expressed with the word per, which means for each. Examples of unit rates: 34 miles per gallon, 2 cookies per person, and 62 words per minute. Click here for a video about Rady the Math Cat. 6 friends have pizza together. The bill is $63. What is the cost per person? Hint: since the question asks for cost per person, the cost should be first or in the numerator. Alright, so here is the rate, $63 for 6 people. Since unit rates always have a denominator of 1, we're going to go ahead and divide both top and bottom by 6 in order to make the denominator 1. When we divide 63 by 6, we get $10.50. When we divide 6 people by 6, we get 1 person. So therefore, the cost is $10.50 per person. The population density of a geographical region is the ratio of its population to its land area. The population is the number of individuals. The population can consist of people, plants, trees, insects, animals, etc. Any unit of area can be used, including square miles, square kilometers, square meters, etc. For instance, we can calculate the population density for humans in New Jersey by following these steps. First, find the human population of New Jersey, 8,791,894 people. Then find the area of New Jersey. New Jersey is 7,790 square miles. Then divide the human population by the area. So divide the number of people by the square miles, and we get 1,129 people per square mile. Find and compare the population densities for humans and bears in Maine, given that the human population of Maine is 1,395,000, the bear population of Maine is 35,000, and the geographical area of Maine is 35,380 square miles. The human population density of Maine, well, we're going to take the population of Maine, the people population, divided by the square mileage of Maine, and we get 39.4 people per square mile. The bear population density of Maine is 35,000 bears to 35,380 square miles, which is approximately 1 bear per square mile. If we want to compare the human to bear population densities, we have the people density here, 39.4. We have the bear density here, 0.99 bears per square mile. Then look what happens. We have people per square mile divided by bears per square mile. So look at this, people per square mile. Now remember, when you divide by a fraction, it's the same thing as flipping and multiplying. So we invert this fraction, miles squared over bears. You can see clearly that miles squared cancels out. So that's why those cancel out. And we are left with people to bears. So the ratio of people to bears is 39.8. The population density of humans in Maine is approximately 40 times greater than the population density of bears. Unit rates are used to make comparisons. For example, Sebastian and Alexandra both worked during the summer. Sebastian worked 26 hours one week and earned $188.50, while Alexandra worked 19 hours and earned $128.25. How do their rates of pay compare? Okay, so we need to figure out Sebastian's pay per hour. So since we have 26 hours in the denominator, we are going to divide top and bottom by 26 so that the denominator becomes 1 hour. 188.5 divided by 26 is $7.25 per hour. We're going to do the same thing over here. Since her rate was given per 19 hours, we're going to divide top and bottom by 19 so that the denominator is also 1 hour. Therefore, the numerator becomes $6.75 per hour. Sebastian clearly earned more, but by what factor? All right, so we are going to divide Sebastian's rate by Alexandra's rate. 7.25 per hour over 6.75 per hour. The hours cancel, giving us 1.074. Therefore, Sebastian's rate is 1.074 times greater than Alexandra's. Or you could think of this as 7.4% more. Jim traveled 480 miles and used 18 gallons of gas, while Tara traveled 640 miles on 16 gallons of gas. How do their miles per gallon compare? First, we calculate Jim's miles per gallon. So 480 miles per 18 gallons. Well, we want the denominator to be 1. So we're going to divide top and bottom by 18. That gives us 26.7 miles per gallon. Tara had 640 miles per 16 gallons. Then we're going to divide top and bottom by 16 so that we get per 1 gallon. When we do that, we get 40 miles per gallon. Then, to compare the rates, we divide Tara's rate by Jim's rate. You can divide either one by the other, doesn't matter. But we get 40 miles per gallon divided by 26.7 miles per gallon. The miles cancel, the gallons cancel. We get 40 divided by 26.7, which is 1.5. Therefore, whoever's on top here, Tara, has 1.5 times the gas mileage of Jim, which is 50% more.